Okay, so let's go with this in hand. Let's go and solve more complex examples. And we're going to have a methodology, okay? First off, I'm being asked to find all solutions of the equation in this interval. So as we've seen here, in a full spin, I can have at most two possible solutions. Moreover, those solutions are going to depend on where the value of that sign lives. So let's go deep into that. I'm being asked to find all solutions for this equation. Remember, finding a solution of the equation means finding the value for the variable, in this case theta. So let's think about first. Let's think about where does this function lives. So this is an angle theta that cosecant of theta is 5/4. So first of all, we know that cosecant of theta is 1 over sine. So we could rewrite this expression as its reciprocal. What does that mean? I can flip this entire equation and rewrite it as sine of theta equals 4/5. Why? Because if cosecant is a reciprocal of sine, that is the flipped version of sine, then we should also flip the right side of my equation. Why? Because remember, an equation is a balance, and if you flip one side, you will have to flip the other one, okay? So with that in mind, this equation is the exact same thing as sine inverse of theta equals 4/5. So again, if you have a reciprocal function, flip your entire equation so you end up with one of the pretty functions that we know, okay? So now that we have flipped our function, let's identify where this value live. So sine of something is 4/5. So what does this mean? This angle theta is giving me a positive value of sine. And where is sine positive? Because sine equals y, sine is positive in first quadrant and in the second quadrant. So the two possible solutions that we're going to find are going to live here and here, okay? So there are our two possible solutions. Positive y, because this fraction is a positive number, so we have to check where sine gives me in return a positive value. Now, to actually find the value of theta, let's do the operations. We know by now that we have to apply the sine inverse to my entire equation. And because I do it on one side, I have to do it on the other side. And when I do this, I know that on my left side, the sine inverse is going to cancel the sine function. So I have theta equals sine inverse of 4/5. So if I go into my calculator, this is sine inverse. Make sure your calculator is in radians. Why? Because I'm asking you the solution in radians, okay? So, and this is actually the typical format in which we ask these problems. So, sine inverse of 4/5. Notice that even though here it says sine to the power of -1, here it writes arc sine. Both are the exact same thing. So this gives me 0.92, round up, 0.93. So theta is 0.93. So this is my first solution. And you're going to say, Andrea, how do I know if my solution is the first one or the second one? So the answer is the calculator always gives you this one, the one that lies in the first quadrant. And I think we talked about this when you were using the law of sines and cosines. This is actually why the law of sine has two possible solutions. So it's like the exact same methodology, okay, to find the second possible solution. So because my calculator gave me the solution And this is for any trigonometric function, okay? If you use a calculator to find an angle, it's always going to give you the angle that lives in the first quadrant, okay? So if I have my first solution, that is this one, how do I find my second solution? By using reference angles. Why? Because by definition, and by what we saw earlier, my second solution has to have the exact same reference angle. The exact same reference angle where? In the second quadrant. So these two angles have the exact same reference angle, right? So I just have to check who's this angle. And this angle, that is actually this one, is just 180, or más bien pi minus theta 1, okay? So my second solution is pi minus theta 1, or in other words, 1 minus 0.93, and that is 0.07, okay? So this is like the important step in solving equations. I will always have at most two solutions. And how do I verify my solutions? The first solution, or the solution that the calculator gives me, is always a solution that lives in my first quadrant, okay? So in this case, my other solution lives in the second quadrant. So I have to find an angle that has the exact same reference angle as the first one, but that lives in my second quadrant. You can always sketch this, and actually I would think if this is going to help you. So you have to have another angle that lives in this quadrant that has the exact same reference angle. So because it lives in the second quadrant, you have to add 180 minus este cachito, minus the reference angle, and that is going to give you the next solution, okay? So there you go, our two possible solutions for this equation. 0.93 and 0.07. No, ¿en qué momento? Pi minus, I don't know how much is pi minus 0.93. Sorry, guys. So this is, I'm just gonna do pi minus answer, and this is 2.21. Sorry, 2.21. So these are my two possible answers, the one that lives in my first quadrant and the second one that lives in my second quadrant. Okay, example number 2. So again, I'm going to continue with the same methodology. So I have to find all possible solutions for this equation where cosine equals something. That something is a positive value. Remember that cosine is equals to x. So cosine is positive in the first quadrant and in the fourth quadrant. So my solutions are going to be this one and this one. So let's go and proceed and calculate the value of cosine of theta. So by now we know that to solve for theta, I have to apply the inverse function of cosine to both sides of my equation. And that is going to give me 999. On the left side, these two terms cancel each other. So I have theta equals cosine inverse of 0.6999. So I know that right now, when I go into my calculator in Chrome, you are not going to see it, but please use your calculator. So I'm clicking in radians and I'm selecting the inverse function of what? Cosine inverse of 0.69999. And the calculator gives me as a result 0.795, so 0.80. So according to my calculator, this is 0.8. Okay? So this is my first solution. Now, this is my first solution. Remember, what does that mean? The solution the calculator gives me is always the one that lives in the first quadrant. So this is theta 1. Now, how do I find this other angle? Well, that other angle, we cannot, because I'm asking you to find solutions between 0 and 2 pi, no me pueden decir, pues es menos 0.8. Why? Because menos 0.8 is not in this interval. So, ojo ahí, because obviously that would be a smart way to do it, but we have to verify where the interval of solution is specified, okay? So I have to find a positive solution. So instead of looking at this, we're going to have to find this angle, okay? But remember, these two angles that are drawn in red have the same reference angle. So from here to here, my value for that angle is theta 1, but also from here to here, we have the exact same reference angle. So this other angle, I'm gonna put it in another color. So this other angle that goes all the way here, que es theta 2, is just going to be a full spin minus theta 1. So theta 2 is a full spin, and how much is a full spin in radians? 2 pi minus theta 1. And according to my calculator, 2 pi minus eso es 5.49. 5.49. So that is a value in radians for my other angle. For those of you who are maybe questioning, why is this solution giving me, if it's in radians, why it is not in pi? Because calculators give you the product. For example, if my answer was to be pi halves, the calculator will actually divide pi over 2 and give me 1.4057 or something. That's why even though it's in radians, you don't see the pi, okay? So, concluding my methodology is simplify my equation to see where both my possible solutions are going to lie, find the first solution, and according to that and where you know your solutions should exist, find the other solution. Let's solve another one. So again, I'm going to start locating where the possible solutions are going to live. I have sine of theta equals minus 2/3. So I know sine has to be a negative value. So the first thing that I'm going to see is where sine is negative. Because sine equals y is negative where? Here and here. So here is where my two possible solutions are going to live. So I'm going to go ahead and solve for theta. So from this equation, I have that seno de theta equals minus 2/3 negative minus 2/3. And I have to apply the inverse operation to both sides of my equation. And because we are adults, I'm just going to go straight forward and say that sine theta is the sine inverse of minus 2/3. Okay, so I'm going to plug this into my calculator, and this is sine of theta of minus 2. So the solution is minus 0.73. And you're gonna say, Andrea, what the hell? You said that my calculator always gave me values or solutions in my first quadrant. And I'm going to tell you, don't worry about it, guys. Just transform it into positive. Take its absolute value. So my first solution is going to be 0.73. Okay, so aquí está el primer level up. This is my solution theta 1, but actually what I want is these two possible angles. So I have to find those angles. My first angle that I'm gonna select in green right here. How do I find this angle? I know all of these angles are going to have the exact same reference angle. All my solutions, eso es importantísimo, all my solutions have the exact same reference angle. So this solution is going to have a reference angle of theta 1, and this solution is going to have the reference angle of theta 1. So how much is this entire angle right here? Well, that means my actual first solution, to make emphasis in this, I'm going to erase this one because this is not like my real first solution. So now my actual first real solution is the solution that lies in my third quadrant, and this is pi, that is a full spin plus the reference angle. So pi plus the first spin, and I said I was not going to name it 1. Okay, so this is theta plus 0.73. And my other solution that I'm gonna color in blue again it's actually this entire circle right here. An entire angle that has the exact same reference angle, rojito, okay? So how do I find this angle? This angle is a full spin minus the reference angle. Do we see it? A full spin minus the reference angle. So my second solution is going to be a full spin minus the reference angle, que es theta. In other words, 2 pi minus 0.73. Remember, we cannot have negative solutions because my solutions have to be between 0 and 2 pi. So if I plug this into the calculator, this is just going to give me pi plus 0.73. This is 3.88. And this is 2 pi minus 0.73, 5.56. Okay, so these are our two possible solutions. So let's recap on what happened here. First off, because sign is negative, we have to verify in which quadrant the sign is negative. And we selected, or we know that in third and fourth quadrant, sign is negative. Then we solved for x and found the solution for theta. And that solution was negative. And we don't want negative answers. So I took the absolute value. Now, the thing is, the solution lives in my first quadrant. So how do I find the solutions that live in the third and fourth quadrant? Well, I know that all of the solutions for these equations are going to have the exact same reference angle. And that reference angle is the one given by the calculator. So that means that this solution in green and the solution in blue have the exact same reference angle but live in different quadrants. So to find the first solution that is in the third quadrant, I have to do half a spin plus a reference angle to get it to that position of an angle. And that is pi plus theta. Then to find the other solution that is in blue is, because it lives in my fourth quadrant, this is a full spin minus my reference angle. Full spin minus my reference angle. So these exercises are a bit tricky because we have to, again, use everything we know. Signs of trigonometric functions, reference angles, and, well, a bit of logic in how to use the calculator, okay? Let's do another example with negative values right here. So again, I have a secant of minus 7/4. So the first thing I have to notice is this is in secant, and I know calculators don't have the reciprocal functions. So I'm going to rewrite it in terms of cosine. Why in terms of cosine? Because I know that cosine is 1 over secant. So if I flip this entire equation, I can have it in terms of cosine. So remember, if you flip one side of the equation, you have to flip the other one. So this equation can be rewritten as cosine of theta equals minus 4/7. Flip your entire equation. Now, ahora sí, let's check where cosine is negative. Why? Because my solution for this equation is negative. Cosine is negative because cosine equals x. Cosine is negative in the second and third quadrant. So, first off, let's find the reference angle or the solution given by the calculator. By now, we should know that theta equals cosine inverse of minus 4/7. So I'm going to plug that into the calculator, and this is going to be of minus 4/7. And according to the calculator, this is 2.18. Okay, so again, ojo, this is a reference angle, meaning that this angle lives right here. I'm going to put it in blue. This is the reference angle we got. But what we actually like or want is an angle that lives here in my second quadrant. I'm going to name it theta 1. And I want another angle that lives in the third quadrant. Actually, what I want is this other angle, theta 2. And what do they have in common? Remember, what they have in common is that all of them, aunque mi dibujo no lo parece, they all have the exact same reference angle. That is, this angle right here is theta, and this angle right here is theta. So how do I find these other angles? Well, let's think about it for a second. Theta 1, that is in the second quadrant, es que it's a half a spin minus the reference angle. So half a spin minus the reference angle. That is pi minus 2.18. And the second angle, or the second solution, that is the purple one, is a full spin plus the reference angle. A full spin plus the reference angle. In this way, my red angle lives in the second quadrant and my purple angle lives in the third quadrant. So if I plug this into the calculator, this is pi minus answer 0.96, and the other one is pi plus sine inverse of minus 4/7, and this is 2.53. 2.53. Sorry about that. A little mistake in the calculator. I put sine inverse instead of cosine, so this is actually 5.32. That makes sense because this pi, que es 3.14, plus 2.18, so 5.32. So these are my two possible solutions, okay? So let's do an example with cotangent and tangent, okay? So first off, remember, cotangent is not a function you're going to find in your calculators. I'm going to flip this into tangents. So I know that cotangent of theta equals 4. And I know its reciprocal is tangent. That is, I can rewrite this cotangent as 1 over tangent of theta, right? I haven't flipped yet. I have just rewritten cotangent in terms of tangent. But when solving equations, I don't want what I want in the other in the denominator. So I'm going to flip my entire equation. And remember, if you flip one side of the equation, you have to flip the other. How do you flip a 4, you would say? Remember that any integer that you have has always a something over 1. So if I flip this equation, this is going to be tangent of theta equals 1/4. Remember, if you flip one side of the equation, you're going to flip the other one too. So this is the equation that I'm going to work with. And by now you should know that tangent theta should be tangent inverse or 1/4. I skipped an initial step. Okay, perfect. That is my reference angle, but I haven't checked where my solutions are going to live. So let's see. Tangent of 1/4. That means that tangent is positive, or in other words, cotangent is positive. It doesn't matter where you look at it, it's going to give you the same solution. So tangent is y over x. So for tangent to be positive, this means that this quotient has to be positive. And a quotient is going to be positive if both the numerator and the denominator are positive, or if both are negative. Why? Because if you had one numerator positive and the denominator negative, this is going to give you a negative value, okay? So we have to check where are both x and y positive, that is in the first quadrant, and where are both x and y negative, that is in the third quadrant, right here, okay? So in these two quadrants is where my two possible solutions are going to live. Now, ya los spoileré, and I gave you the first, or maybe the reference angle. This reference angle lives in the first quadrant, and thank Jesus Christ, is going to coincide with my first solution. Why? Because my first solution also lives in my first quadrant. So my first solution is the exact same thing as the reference angle, and if I plug it into the calculator, tangent of 1/4. This gives me 0.24. So this solution is 0.24. Beautiful. We have one solution. Now, where is the other one? The other solution lives in the third quadrant. And I know that that solution is going to have the exact same reference angle. So how do I find this angle? That this is actually my second solution that I'm looking for. Remember, we're always looking for positive numbers. So I know that this second solution lives in my third quadrant and has the same reference angle. So how do I find it? Well, this angle has or does half a spin of a circle plus the reference angle. So my second solution is going to be half a spin plus my reference angle. In other words, 3.1416, guácala, plus 0.24. Y voy a decir que más o menos esto es un número conocido as 3.38. Okay? Ta-da! These are our two possible solutions. And let's do one last one. I think I have a tangent right here somewhere. Oh no, it's a sine inverse. Okay, I'm gonna do it just for fun. Woo! So, first off, let's check. This is a sine inverse. This is a basic solution. This lives in my calculator. So now what I have to do is check where sine is negative. Sine is negative in the fourth and third quadrant. Why? Because sine equals y, and sine is negative in these two quadrants. Now, to find the value of theta, we are experts now at applying sine inverse, and if I plug this into the calculator, this is going to give me theta equals, a ver, 5831. Minus 0.62. Minus 0.62. And remember, I don't like reference angles being negative. So I'm just going to switch its sign, or más bien take the absolute value. Now, that reference angle actually lives right here. Okay, so this is theta. But again, I don't want that reference angle. I want a solution, a first solution that lives actually in the third quadrant, and I want another solution that lives in the fourth quadrant. So this first solution, theta 1, remember, has the exact same reference angle theta. So this right here is theta, exactly like this one. So the value for theta 1 is half a spin plus un cachito. Half a spin plus the reference angle. 3.14 plus 0.62, and this is 3.76, 3.8. And what happens with my other angle? My second solution is in the fourth quadrant, but remember, it has the exact same reference angle, but I want a positive angle, so I cannot just take the negative one. Remember, my interval is positive. So the angle that I'm looking for is actually this one. And this angle is a full spin minus a reference angle. A full spin minus the reference angle. And this is 2 pi minus answer. O sea, hace 6.90. And these are my two possible solutions.